And we were on item H4, the annual beach monitoring survey report. David?
Good morning, Mr. Mayor, Board of Commissioners. At your June 3rd, 2020 meeting, the board approved professional service contracts for McKim & Creed for beach surveying services and also to Moffitt & Nichol for coastal engineering services. The scope of work was broken up into several tasks. Task 1 being an annual beach monitoring survey, which was comprised of both land and water-based surveys along with supplemental engineering analysis. Task 2 was comprised of year 1 of a multi-decadal beach nourishment master plan. Task 3 consisted of engineering support for a coastal storm damage mitigation grant application, and Task 4 consisted of post-Dorian beach restoration engineering support services. So here today to go ahead and give you an update as to the progress of those tasks is Mr. Johnny Martin and Mr. Brian Joyner of the engineering firm Moffitt & Nichol.
Thanks, David, and good to see y'all. And you said I could just do it with this mouse here? Okay. All right, good. All right, so one, we'll kind of, I know you needed the bathroom break because you know that when engineers speak, we can't speak too quickly, but we're going to try to make this as quickly as we can. But there's a lot to go over, so me and Brian will do our best. But first, I want to start off with some of the overall project progress that David was just doing and get into some of the data collection, the project methodology, some of the key events that really affected the beach over the last year, as well as sort of our summary of findings. And then Brian will also then go into the master plan update, and then we'll have some Q&A. So just overall, for the annual beach monitoring, that's now 100% complete. As far as what's going on with the master plan, there is a lot of data that we've been getting from the previous consultant, so that data collection and review is roughly about 50% complete. Task 2 within the master plan is some of the modeling and development of the nourishment needs. That's roughly about 25% complete, we estimate. We've completed the GenCade model calibration. The GenCade model is the one that sort of simulates longshore transport. So a lot of times when we're talking in coastal engineering, we'll talk about the sand that's moving up and down the beach as well as on and off the beach. So a longshore transport is the stuff going up and down the beach, north and south, and the cross shore is the onshore offshore. So we've begun the seashore beach profile setup, and that of course will be the onshore offshore, looking at storm impacts and things of that nature. As far as the CSDM grant process, we're awaiting notification from the state on that, but we hope that we will know for sure something within the next 2 to 3 days. So I'll start with the data collection. So again, this being the first year, and then so many things happening, we actually did a little bit more analysis in this study or this year's work because we needed to take into account the summer survey that McKim & Creed did for us, as well as then looking at the post-Dorian survey, how much changes happened from post-Dorian to now, the summer survey that CS&E did, because again, the monitoring report is really a year to year, so the basis of it is looking from the 2019 summer survey to now. But then there was a nourishment action that happened just before that. So again, when Brian gets into a lot of our discussion, you'll see we tried to break up things about what's happened over the last year, but then what's happened in between each one of those steps. So another thing that we'll say, talk about here is the nourished oceanfront versus the total monitored oceanfront. So when you see that information, you'll see some of the tables in the report. When we turn that in, you'll see that we kind of broke down some of the results from the nourished oceanfront is where the beach is nourished or where the nourishment is placed. But then also the total monitored oceanfront, which includes some of the areas in Nags Head North as well as south of the town limits that gets down into the National Park Service. And actually this year we added a number of profiles, as you guys know, just so that we could get sort of consistent distances between those, and especially getting some more detailed information in the hotspot area, because we really want to try to start getting a feel of how that's happening. Again, we made those recommendations based on the fact that looking at some of the historical data over time, you would see these sort of big shifts even at 500-foot spacing, so that's why we went to a narrower spacing in that area. So the survey was performed by McKim & Creed, as David said. This is some of the equipment that they use. I'll go into the project methodology. So of course, we measure the shoreline change at mean high water, which is roughly we should just say 1.2, but just, 1.18 feet NAVD. We just want to keep it consistent with what's been done in the past. So there again, you will see that elevation is roughly right here along the shore face. And then we kind of denoted the beach berm here. I'll talk a little bit about some of the nomenclature that we use in some of these coastal engineering analysis here in a second. But in addition to the shoreline change, we also do volume change calculations, and we look at that to kind of measure how much the beach face and the volume is changing at different elevations. So we do it from the top of the dune out to +6, which is really, the berm elevation. We go out to mean high water, -6, which is approximately the wading depth, what we say, -14, which is the outer bar, -19, which has sort of been set as the depth of closure here for, all the projects that have been done in the past, -30, which is even further offshore. And what we do is we calculate, and we use these volumes for calculating the volume changes as well as updating background erosion rates. So again, why is this important? Because again, this is your protection. This is the way I kind of like to, talk about this, is this sort of area of sand is what absorbs wave energy. It's what's protecting your oceanfront infrastructure. So what we want to do is we do want to see, okay, how is this changing over time with, this volume above +6, roughly the berm elevation, mean high water, out at -6, out at -14, and then going out to 19. There again, as Brian will show you here in a little bit, this shore face is really what's taking the brunt of the storm impacts and moving material, in some cases, up onto the beach as well as offshore. It has been a fairly active season here, since the August 19 survey. We had Hurricane Dorian that had some offshore wave measurements of roughly 14.6 feet. So this is up at the Duck Pier. But we also had the nor'easter storm that you see here, and it actually had higher wave heights than the Dorian event. As Brian will show you, there was a lot of change that happened in between the August survey and Dorian. Some of that is probably due to the storm impacts, of course, as well as some of the natural equilibration of the beach face, right after these events.
John,
But,
just real quick, is there any significance to the dotted line at 8 and 12?
It's just something that we kind of are, looking at and, just kind of seeing how often it got above those. It looks, that was just sort of a visual thing that we did there, just to kind of see, okay, these larger events. As we get more into the modeling, we'll be able to see if there's some of these types of events that really are important as far as moving at the amount of sand as part of the master plan. But right now, this was just sort of a visual thing to say, okay, it looks like only above -8 is when we're getting into something, fairly significant, and then, something really significant above elevation 12. So that was just a visual. But as we get more and more into the study of the master plan, we'll be developing some statistics to kind of be able to quantify, some of these different breakpoints. Of course, you also had the Nourishment event in 2019 that placed roughly 4 million cubic yards along 10 miles of the beach. And I'm going to turn it over to Brian now to kind of go over sort of the summary of findings.
All right. Thanks, Johnny, for this setup and explanation of the terms. So, point the mic at myself. I'm not so loud as some.
So you can understand.
So if we get into what we found from the data that was surveyed in June of this year, we found volume that was out there, shoreline that was out there, but it's really meaningful when we compare it back to what happened right after the Nourishment project, which was surveyed in August last year, and then right after Dorian, or the post-Dorian survey in November of last year. And there's a couple of key takeaways. They're not bullets on the slide. I'll just verbalize those. The The key takeaways are, as you've seen, as your public has seen, the shoreline has receded since the shoreline's come back landward since the Nourishment project ended last year. The number's a little small, but on average about 90 feet landward recession in the Nourished area, and about, if you take the larger extents of the town, the surveyed area, the average goes down, but still about 80 to 90 feet of recession over the last year. And you see that in the volume change that people can see. So the volume of the beach that you can see above mean high water or mean low water has also decreased pretty substantially over the last year. And as we'll see in a moment, most of that, in fact almost all of that, was due to Hurricane Dorian. And we actually saw a recovery, gain of sand in that visible area since Dorian to now, or to the summer. And the other takeaway is, even though there was loss where you can see the beach, there's actually relatively little loss and or gain in the overall beach system out to what we call depth of closure, so where the profiles kind of tie together, where we expect normal year-to-year wave action to move sand. So of the sand that you placed last year, it varies reach to reach, north and south along the beach, but as a system as a whole, most or all of that sand is still there in the system, available to absorb wave energy and to maybe migrate back and forth into the bar. So we'll try to illustrate that in a moment. We have the numbers here. I won't go through them. We have them for discussion if we need to. The first column here documents the shoreline change from north to south. Top of the table is north, bottom of the table is south near the inlet, and the green area here is the Nourished Oceanfront, so where you actually placed the sand last summer. And again, it just documents reach by reach how the shoreline changed. We'll take that into a bar graph, though. It's just easier to see at this scale. So the north end of the town is on the left of the bar graph, reach 1, that's the longest reach. We use the reaches that are documented in the nourishment plan, so how Great Lakes reported the sand, how previous consultants broke the beach down. So the first third or so of the town is reach 1, reach 2 is a long reach there in the middle of town, and then reach 3 and 4 are getting closer to the hotspot area at the south end of town. And you can see the green line is the shoreline position, the shoreline position right after nourishment was completed last year from a baseline. And the red bar is how far the shoreline receded. So is the shoreline position right after the Dorian survey, post-Dorian survey. You can see a fair bit of shoreline recession due to the hurricane. And the blue bar is the shoreline position as surveyed this summer. So not a lot of change, actually. A little bit more recession in the north end of town, fairly stable in the middle of town, more recession relative in the south end of town. But again, the bulk of that change in the shoreline was due to Hurricane Dorian. If we go to volume change, it's complicated to show on any one graph. We're just illustrating the variability in the volume change over the beach from the north end of town on the right of the figure, the south end of town toward the left of the figure, and then the inlet all the way over to the extreme left on the map. Volume change is very noisy. It's a very noisy signal when we measure that transect by transect by transect. And so we try to categorize that in reaches or groups. Again, we have a table. We can dig into the numbers if there are questions. The numbers at the bottom of the table, especially in the green row here, summarize what happened over the entire Nourished Oceanfront, so where you actually place sand. There was a gain of approximately 100,000 yards, a couple 100,000 yards in the beach above the berm, so up around +5, +6 feet and up into the dune, where people would generally be sitting on the beach recreating and walking through the dune. There was a gain there overall throughout the year. I'll kind of illustrate why we think that happened in a moment. As I said, there was a loss of on the order of 1.5 million yards between basically the mean high water shoreline and out past the sandbar. There was a loss of sand in that area that migrated slightly further offshore, but overall, above about -19, -20 feet, where the sort of profile starts to tie together year after year after year, the depth of closure, there was a gain over the entire year, even considering the effects of Hurricane Dorian, of about 250, 300,000 yards over the entire Nourished Oceanfront. Trying to illustrate that a little more graphically in a moment, but the reason we think that what we believe happened, and what's usually borne out by modeling and other analysis that we do, is on the beach, when you have a nourished beach, you create a much wider dry beach. When you have a wide dry beach, wind can move the sand around. And waves can also push sand a little bit further back up on the beach when they're not massive storm waves. As the wind and the waves move the sand up, the wind can blow the sand up into the dune. So we see a red arrow moving back landward on this figure, which we believe a lot of the gain in the dune was due to the fact you have a wide, dry beach and sand can move up into the dune that way. At the same time, you have storm waves and just all the waves that Johnny, that were on Johnny's slide and that Commissioner Fuller asked about. Between that maybe 8 to 12 foot wave height range, you can start seeing sand pulled off the beach and out into deeper depths, like around the sandbar. So where we see the sand loss, it's sand moving to the right on the figure, out into deeper water to the sandbar, but eventually being captured, as we saw in the data, above about -19, -20 feet. So what is observed with the eye when you walk out on the beach is a big loss here in the edge of the beach, the intertidal zone down to mean low water. It looks like there was a lot lost, but a lot of that sand is actually still there, which we see as the value of taking these very long profiles, and a lot of them along the beach. If we take it elevation by elevation, so imagine you're standing on the beach, near the back of the beach, looking landward. If you could judge it with your eye, you'd see a gain in volume from the end of the nourishment condition. You can see this green bar here. That's what it was at the end of the nourishment last year, and the blue bar indicates gain back in the dune. And we saw that all along the beach, but less of it down in the southern end of town, more of it in the north end of town. If you are looking above mean high water, so if you're out at the edge of the water at mid-tide, looking back at the beach, if you could see it, you would see a loss from the end of nourishment to after Dorian. You would see most of that loss, and then a little bit of gain actually in the north end of town from Dorian to now. Same thing in the middle of town, and even down toward the south end of town, getting near the hot spot. And only really in the hot spot did we see a loss throughout the year. Did we see a loss after Dorian from that condition, above mean high water, above the shoreline. Looking above -19 though, so this depth of closure, where when we do our modeling, where we see just physically in profiles throughout our experience, the sand remains in the system, it moves back and forth, sometimes back toward the beach, and is still available to mitigate wave action. We saw at the end in the north end of town, at the end of nourishment, this green bar, and actually a gain of, I think the number is like 40% more, no, not 40%, about 14% more sand in the system in the north end of town than there was when you finished the nourishment project last summer. And a similar story in the middle of town. You can see Dorian in the middle was a loss and then a gain back. Near the hot spot, in middle to south end of town, about the same amount of sand in the system as there was right at the end of nourishment. And then only really in the hot spot area at the south end of town did we see an actual loss for the whole year net of sand as it migrates south toward the state park. Just another way of looking at all that data together for the whole oceanfront. We've been through the story. We can refer back to this in a minute, but a gain above 6, a loss around the shoreline, but then a total net gain on the far right bars is the above depth of closure gain throughout the whole system for the year. I'm gonna hop through that and that. We've been talking about volumes in absolute numbers so far, cubic yards, but it helps because the reaches are different lengths. So reach 1 of town is a very long reach that acts a certain way. Reach 3 and 4 at the south end of town in the hot spot are much shorter because things change much more quickly. So when we talk about absolute volume yardage, it's hard to compare the numbers, but if we compare it on a cubic yards per foot, so how much volume is in a given slice of the shoreline, it's easier to compare them together. And we saw this one, to me, definitely illustrates, and the easiest one to see is the purple bar in the middle. The volume loss as you move along the beach in a given slice is less in the north end of town, in the middle end of town, and much greater down in the hotspot area, which we knew from experience, but this is a way to document it and try to explain it, illustrate it. We did compute, I won't get into the numbers in the table. In addition to just looking at volume change over the last year in preparation for taking this data into the master plan, the multi-decadal master plan that Johnny mentioned, we needed to compute the background beach erosion rates. So what is the long-term in the absence of nourishment, which changes obviously the beach position, but in the absence of nourishment, the long-term erosion rates have been calculated. They vary a little bit along the beach. So we'll have that data to go forward. And we did look also at long-term changes in the dune, so above the back of the beach, above about plus 6 feet. As part of the master plan, we're going to be looking at what protection does the beach, but more especially the dune in front of structures, the dune in front of infrastructure. How robust is that? How much is that dune growing year by year or shrinking? And I apologize, the yellow showed up a lot better on my computer screen than it does on this distance chart here. But we computed the change in the dune volume from 2011 to about 2018 using a moving average, trying to smooth it out and understand trends, and found that except for a couple of spots, one up pretty much opposite Jockey's Ridge in the north and one down in the hot spot in the south, the dune over time is actually growing, gaining volume year by year, which is good. That'll definitely feed into our study and recommendations of what to do with the master plan. And then having these two areas that we know it's not growing and or shrinking in any given year will let us come up with mitigation options or ways to manage that dune volume so that we can provide, I think we mentioned back in the summer when we first talked about this project, a way to approach this is try to provide equal protection along the beach at least, so we're providing a level of protection from a certain kind of nor'easter or a certain kind of hurricane in the north as well as in the south and in the hot spot. So this data helps us to come up with strategies to manage that. Before I go into the master plan update, I guess I should stop and ask if there's any questions on all that data, because we're changing subjects here in a minute.
Mr. Martin, do you feel that any of that growth on the north end of the beach is a result of the beach nourishment to our north?
It could be, but, I think that it takes a while for those for that material to come down. I mean, the fact that it's been a few years, maybe you are getting some of that material that is coming into the system. I know there's like this gap, but, that is probably helping some as far as when we get into the modeling and whatnot, and we are really kind of able to get a sense of those longshore rates. We'll be able to see how much of that is maybe due to that longshore transport versus sort of the building of the wind and everything else as you guys put this material back out.
Thank you.
Thank you.
All right. Just a real quick update on the master plan process itself. We have started into that. Johnny covered a lot of it. Just to illustrate, there's multiple phases. There's the data collection and analysis phase, which we think we're about halfway through. We still have some sediment data to look at to try to make sure that the identified and permitted borrow areas offshore, that they contain the amount of sand that we think they contain, and that all that sand is going to be useful for a 30 to 50 year beach nourishment program. So we know whether or not we need to look for other sand to accomplish whatever goals were set through the process. And then we're about 25% complete with some of the modeling and analysis that gets us to the point of knowing about how much sand you would need year to year and over the decades to carry out this program. We're working on the seashore stuff this week, trying to understand how much protection the dunes offer so that we can make some good recommendations about that. And those two tasks, we've committed to have those complete and be able to present back to you on some findings by early spring. Certainly there'll be interim updates before that to town staff, and then we'll certainly answer any questions you have on that or other stuff in the meantime. So I think that's the end of my presentation. Is there any additional questions?
Any additional questions, board? Observations? Great, thank you.
All right. Thank
Commissioner Kuhn made an observation that I'll echo. Like the way you guys described this, you talked about wading depths and physical aspects of the beach nourishment that people can see and kind of relate to, and not just numbers. We find that to be really helpful, and it certainly can also help us communicate these ideas to the public when that becomes necessary.
That'll be real key when we get into the master plan and all of that too, because again, it's always this, I'm sorry, and the reason to also do that is be tracking not only at 19, but some of these areas that people visually can kind of touch and feel, and that's what they see, right? Because, it's one thing to talk about things in the ethereal, but, you need to talk about why these things are different at the various elevations. And, as far as some of the master plan stuff, and we're looking at triggers, we will not only be looking at, what do we need to have on a cubic yard per foot basis above 19, but we also want to be looking at, okay, what would that be at 14 and what would it be at 6? Because depending on how this may go, you know, we may change the way some of these nourishment triggers are set up.
Right. Yep.
I'm very appreciative of that. I think our citizens will be too, rather than talking about a sandbox. Relatable benchmarks are where we need to be. Thank you.
Great. Thank you all very much.
Thank you.
Closed session.